Hi, in our last lesson, you learned how to solve a three-variable system using substitution. So today we're going to do a different system that's called Gaussian Elimination, and that is going to use something called an augmented matrix. In order to do a matrix, you're going to take the system that we have written down here, and we are going to look at the number of rows and the number of columns, and we are going to take the coefficients of the variables that are in each of the rows. So this particular system has 3 rows and it has 4 columns when you do that. So we're going to use braces and we're going to take the coefficient of each variable. So there's 1x, 1y, negative 1z. We're going to draw a line that's going to separate the equation from the answer, and then we're going to put the constant 7 there. Go to the second row, 2, 1, 1, 9, 1, negative 1, 2, 3. So we now have our augmented matrix that we're going to try to work with. The goal of Gaussian elimination is to make sure that you have 1s along the diagonal of the matrix. So you might have 0s here, you might not, but this needs to say that it has a 1 when you're working through the problem. Okay, so we're going to take this and we're going to, there's a 1 here, so we start in a good place, but this is a 2. This needs to change to a 0. So we're going to take 2 times row 1 and we're going to subtract row 2, and that will give us our new row 2. So 2 times 1 is 2, 2, negative 2, 14. Row 2 would be 2, 1, 1, 9. And I'm going to subtract to get my new row. So 2 minus 2 is 0. 2 minus 1 is 1. Negative 2 minus 1 is negative 3. 14 minus 9 is 5. So this becomes our new row 2. So we're going to take and we're now going to rewrite the matrix. We keep the first row. And now we're going to input the new second row. 0, 1, negative 3, 5, 1, negative 1, 2, 3. We haven't done anything to change row 3. So now I have a 0 here, and I need to get a 0 at the beginning of row 3. So I'm going to take row 1, and I'm going to subtract row 3 to make the new row 3. So 1, 1, negative 1, 7, minus 1, negative 1, 2, 3. Whoops. So we need to subtract the row and not just change the sign. So 1 minus 1 is 0. 1 minus negative 1 is 2. Negative 1 minus 2 is negative 3. 7 minus 3 is 4. So our new, we will now rewrite this matrix with a new row 3. So that now keep row 1 the same. Now I want to keep row 2 the same, and I'm going to input my new row 3 to negative 3, 4. Alright, so I have a 0 here, a 0 here, a 1 in this part, a 1 in this diagonal. Now row 3 needs to become 0. So I need to take 2 times row 2, subtract row 3 to make your new row 3. Okay, so now we're going to double row 2. So 0, 2, negative 6, 10, and subtract row 3, 0, 2, negative 3, 4. So 0, 0, Negative 6 minus negative 3 is negative 3, and 10 minus 4 is 6. So now we're going to input the new row 3 on our matrix. So keeping row 1, keep row 2, and put the new row 3, 0, 0, negative 3, 6. Okay, so now we're almost there. We just have to fix row 3. So we're going to take negative 1/3 times row 3 to get your new row 3. So that will become, so now we're going to take negative 1/3 times the last row, 0, 0, negative 3, 6. So that gives us 0, 0, 1, negative 2. Okay, so that's our final row, and it makes our final matrix, which will be 1, 1, negative 1, 7, 0, 1, negative 3, 5, 0, 0, 1, negative 2. So now you can look and see that our final matrix has the diagonal that is 1s all down through the diagonal. Now, using what you learned from the last lesson that you had, I'm going to rewrite this. So we had our final matrix was 1, 1, negative 1, 7, 0, 1, negative 3, 5, 0, 0, 1, negative 2. Okay, I'm going to do backward substitution. Okay, we're going to use backward substitution. So this says z is equal to negative 2. So that gets us the first number in our triplet. Now I'm going to take negative 2 and I'm going to substitute it in here. The second line says y minus 3z equals 5. So I'm going to take and I'm going to substitute negative 2 for the z value. So y minus 3 times negative 2 equals 5. Y plus 6 equals 5. Subtract 6. Y equals negative 1. So now I have the second number in my triplet. Now I'm going to take both of these to put into my top equation. So that says x plus y minus z is equal to 7. X, and we know that y is equal to negative 1, so plus negative 1, minus z, which we know is negative 2, is equal to 7. So x minus 1 plus 2 equals 7. So x plus 1 equals 7. Subtract 1. X is equal to 6. So take your variables and put them into your triplet. X is 6, y is negative 1, and z is negative 2.